So let's get started. Okay, so here's a quick agenda, things we're going to cover. We're going to go through what is a graph, how does it differ with a relational database versus a NoSQL database, and we're going to go to a quick demo, and then we're going to go over various use cases and whatnot. Okay, so quick introduction. TigerGraph was founded 5 years ago. Our mission is to unleash the power of interconnected data for deeper insights and better outcomes. So it was founded by Dr. Yu Xu, who comes to who did a stint at Teradata, where he was the architect of their MPP architecture solution. After that, he went over to Twitter, where he spent some time working on the Twitter's graph database, and that's where he got the inspiration to build a high-performance native graph database that's MPP for the commercial market. We're headquartered in River City here in San Francisco, right next to Oracle. Okay, so here are some of the customers that we have: Visa, Intuit, Wish.com, China Mobile, and so on. So what is a graph, right? A graph is an intuitive way for you to model real-world entities, especially very interconnected type data. I think you'll find it a very natural way of modeling a schema. So for instance, you can model entities like users, customers, employees, their profiles, what is their browsing history, what have they purchased. We can model all that as vertices and edges, right? This is the way you think. And then use the power of graph analytics for use cases like recommendations engine. Use it in supply chain to predict impact analysis, right? What if something goes down, or who needs to be involved and all that. We also see a lot of use cases, especially in the anti-fraud, cybersecurity, as well as anti-money laundering. New use cases pop up all the time, and we'll dive into that a little bit further. Okay, so we use graphs every day, whether you're aware of it or not. Every time you do a search on Google, Google uses something called a PageRank to give you a sorted list of result sets that's most pertinent to your search. That algorithm is called PageRank. It's a graph algorithm. Here's a quote from Gartner. Graph analysis is possibly the single most effective competitive differentiator for organizations wishing to pursue data-driven type operations and decisions. Okay, so the Googles and Facebook of the world, they use and leverage graph technology for competitive advantage. These 4 companies alone, they combine for a total of a 2.5 trillion market cap combined. Okay, so very quickly, just to show you, if you were to go to Google right here, if you type quick search like this result set is using a graph algorithm called PageRank. This right here, this info box right here, is various data points coming from various sources that Google has accumulated using something called the Google Knowledge Graph. So just the simple search like this, you are involved in 2 different use cases for graph, right? So let's do another search. And then clicking on this link here, I have a Ghostery plugin that tells you the various people that are tracking your visit to this website. On dbta.com, on one of my visits to dbta.com, I was able to see in my plugin Facebook social graph, right? So this is a simple act of searching for something on Google and then clicking on one of the links. You just participated in 3 use cases for graph. Okay. So next, here's a more recent press release from Gartner from just last month in February 2019. The top 10 data and analytics technology trends for 2019. For the first time, Gartner described what is graph analytics, and graph analytics is essentially techniques that allow you to explore relationships between different entities that are of interest to you. This could be people, customers, the purchase history, what transactions they've made, and so on. Gartner went on to predict 100% annual growth in graph technology through 2022, okay? And the reason for this is because they see a growing need for people to ask complex questions across large data sets, large complex data sets, and oftentimes this is just not practical or even possible with a relational database query, especially at scale. And later on when we do a demo, we're gonna show an instance of this. Okay, this is just more evidence that graph databases are growing in popularity. According to dbengines.com, you can see on the link right here, graph databases is the fastest growing category in data management since 2013. So what exactly is a graph database? How is it different from a relational database, as well as how is it different from a NoSQL database? Okay, so we have on the left-hand side here, relational databases, which is an excellent solution for transaction systems, for OLTP. However, you do have to adhere to a very rigid schema that's either third or fourth normal form, right? So an OLTP schema is great for write transactions. For any kind of queries that requires a lot of joins, like 3, 4, 5, 6, 7, 8, this is not an ideal solution, as you will see later on, right? In fact, to do analytics, oftentimes in the relational world, you have to embark on an ETL process. That could be one day, it could be a few days before you can actually get to any kind of serious type of business intelligence. Okay, so you end up with two systems, one for transactions and one for analytics. Next up, we have the key value databases, also known as NoSQL databases, very popular of late in the last 10 years, actually. They're very good, but for very simple and fast access to the database just based on your key lookups, right? They don't come with a schema, so hence there's no SQL or no query language that you can use. So what that means is for any kind of queries other than a key lookup, you need to program your queries. You need to program it in a language like Java or JavaScript. For analytics, you then need to rely on peripheral systems like Hadoop, like Spark. So again, you have two systems, two silos of data, one for transactions and one for analytics. Next, we have the graph databases, which have been gaining in popularity, right? With graph databases, you have a lot of flexibility how you want to model your schema. And depending on your choice of vendor, you can have both very high performance on transactions as well as high performance on your deep link analytics type queries. Okay, so this is how we see graph databases evolving over the years, right? Graph databases actually have been around for quite a long time. We see three generations, Graph 1.0, 2.0, and 3.0. So Neo4j, which is Graph 1.0 technology, they started out more than 15 plus years ago, okay? A few observations, right? Clearly, Graph 1.0 type products are not architected for big data. They're great for loading up and visualizing small to medium-sized data sets, perhaps offline. And we can make that deduction just based on the fact that it only supports a single server, right? It doesn't, once you max out on that single server, that's it. You cannot scale out on a large data set across multiple machines. We had a customer come to us once. They tried to load up about 30 terabytes of data into Neo4j. It took about 15 plus days and counting, and ended up not finishing, and they just gave up. Okay. Next, we have a Graph 2.0 vendors, and these are the products that persist data in a NoSQL or key value store, and then they have a graphical representation of that data in memory. Okay. Certainly, with NoSQL databases, you can distribute, you can support a large data set. However, not all of them, not all Graph 2.0 vendors support ACID. Not all of them support real time. And what's key also is because of the architectural mismatch, the impedance mismatch between a NoSQL database and a graph, oftentimes they're very poor at handling multi-hop queries. Okay, this is what we call deep link analytics. Essentially anything that's above and beyond 2 to 3 hops. Next, we have the Graph 3.0 generation, which we believe is the latest one. Graph 3.0 is where you're starting to see graph databases grow up and mature, so to speak. You're starting to see features that are worthy of large enterprise deployments. So with that, let's go on to see what makes up a Graph 3.0 database. TigerGraph is the 3rd generation of Graph 3.0 graph database. Starting from here, we're built to scale, right? Billions of entities, trillions of edges. We're built to serve like petabyte scale type data, okay? It's transactional. We support simultaneous reads and writes. Thousands, hundreds of thousands of updates per second with real-time performance, oftentimes in the sub-second category for queries that are touching millions or even billions of data and relationships. The key thing for Generation 3.0 database, we believe, is the ability to do what we call deep link analytics, deep link multi-hop analytics, right? So we have customers right now in production that are doing 10 plus hops in their queries. And we'll show an example of this in the demo coming up. Okay, TigerGraph comes with a visual SDK called Graph Studio, and that's part of the demo later on. We have our own GSQL language, query language, which is Turing complete. It allows you to essentially write a store procedure for graph. And we have a user extensible open source GSQL graph algorithms library that comes with it. Last but not least, enterprise-grade security, encryption both at rest as well as in transit. We also provide role-based access control for very fine-grained control for how you want to share a graph, you know, who can do what. In a large graph deployment. Add CPUs, cores, increase the memory. At some point, you need to scale out across multiple machines, right? So this particular customer has 6.6 terabytes of data, which is about 20 billion vertices and 95 billion edges. We load it up in 4.5 hours on 24 machines with 128 gigabyte each. And this is able to power queries, 11 hop queries in 129 milliseconds per query, giving you 2.3K QPS, okay? So we categorize graph analytics, or if you want, you can call them graph design patterns, into 4 main categories. These are the types of things that you cannot do in a SQL database, right? So link analysis, right? So something, an example of that would be looking for the shortest path between 2 nodes. Subgraph discovery, to be able to do K-hop queries. Pattern matching, to detect similarity using algorithms like cosine similarity, jacket similarity, and then we actually do temporal pattern matching as well. And then the last category is called hub and community detection. So this is your page rank, your centrality algorithm. Example of that would be, you know, what's the most influential node in your graph, right? So if you have a graph of doctors or medical practitioners, which one of these doctors in the particular region does the most number of recommendations to other specialists and whatnot. Community detection, and so on. So a lot of these categories, we have our Graph Guru webinar series, and you can sign up for various episodes. Like for example, episode 5 dealt with page rank, episode 6, community detection. Okay, we'll have an example of this. Okay, so let's go to a quick demo of what we mean by graph analytics. This is our test drive. You can sign up for a free account and essentially take a test drive of the product. 5 different types of use cases Okay, every one of these use cases comes with a short YouTube video that you can watch, kind of previews it and explains what the schema is and whatnot. And then you can actually try it, right? So we're gonna, since we talked about social graph earlier, we're gonna try this one here. So this is Graph Studio. Okay, it's a UI that comes with the product. It's nice because you can just drag and drop, design your schema, map, load up data, and then actually use it like an IDE to write GSQL queries. This is by no means the only way you can access the platform. There's also command line scripts. Everything is REST APIs, right? So if you want to do it programmatically, it's also fine. So let's just walk through the schema real quick, right? So this is a social graph, law enforcement if you want. So at the middle, this is a label property graph. You have properties on your citizen vertex type. We know the train rides, the bus transportation rides that this person has taken, all the flights, the bank accounts belonging to this person, what kind of transfers have occurred, train, phone numbers, and phone calls, right? So you can easily reskin this to fit your use case, right? It could be KYC, it could be a customer 360 type use case, okay? Here are the edges and so on. Next, you can map data to your schema, right? So for instance, you can load up CSV files and then map it to your schema, right? So you drag and drop. So for example, here you have a file called bank transfer records from a CSV file, your sample data for the various columns, and you can just drag and drop and map it to your Vertex property type. Vertex type properties. And we have helper functions like GSQL concat that allow you to concatenate multiple input columns and then have the output mapped to a single property here in a vertex. And you essentially do the same thing for the relationship, for the edges. Okay, again, drag and drop. And we are mapping stuff to the money transfer edge type. Okay, this is a read-only instance, so data is already loaded for you. Okay, once it's done loading, you can just hit this, and when it's done loading, you will say done, all around, right? And then you will see this in real time go up as the data is loaded. So we have a total of 1.2 billion vertices already loaded, and a total of 4.5 billion edges loaded, and that breaks down to like 10 million home addresses, almost 40 million citizens, 50 million hotel room events, and so on. So you can sign up and see for yourself. So it's not a huge data set, about 5.5 billion vertices and edges total. Not huge, but meaningful for a demo. Okay, so this is where you can write queries, right? This is an example of a GSQL query. It does something called connection mining. It takes two vertices, one for each citizen. And the question you want to ask is there a connection between these two? Okay, if any. Right, so here's our GSQL query. Okay, so let's go ahead and run this. Right, let's say you have citizen 1, 2, 3, 4, 5, and 2, 3, 4, 5, 6, and you want to see if there's a connection between these guys, and you want to go to 5 levels deep, and you run the query. So the query comes back as a graph, and the answer to that question. So here's citizen 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5. And the answer to that, of course, is yes. That we find multiple connections between the two of them, right? So let's just go through one of these guys. This person had a hotel room event with another citizen, Stella. who has a bank account that was part of a bank transfer event with another bank account belonging to this person, who then transfer money to another bank account belonging to this person. You can see, you can trace the whole thing back to, not back, but all the way to our other target person here, 1, 2, 3, 4, 5. So let's pause and step back to reflect on what just happened here, right? For some perspective. I put in 2 input vertices, right? And I wanted to see if there's a connection between these 2. And you can see that on a data set of like 5.5 billion vertices plus edges, the result came back in sub-second response time. And we're able to do this without any caching. And we'll come to the reasons why that is so, why it's so fast later on. But now I just wanted to ask, right? Given that each hop here is potentially a join, right, in a relational database, well, how are you going to achieve this in a relational database, right? So I'm just eyeballing it here, visualizing. It's like 10 plus, maybe even 14 plus hops, right? And we found a few of these, right? The answer to that is it's unlikely that you would deploy something like this on a relational database. It's just not practical for it to come back in any kind of reasonable time frame. Okay, so that's what we mean by link analysis, one of the design patterns. Okay, so let's go back to our slide deck here. So this graph, this chart basically says for analytics, deep link analytics of the graph nature, you probably don't want to use a key value data store. You probably definitely do not want to use a relational database because of the number of joins that you have to do. This is where TigerGraph excels. Okay. So let's go through other use cases. So here are the 3 big ones. Wish.com uses TigerGraph for a recommendation engine, next generation recommendation engine. They're able to grow to like $10 billion annual revenue in 6 years with TigerGraph. We have China Mobile using TigerGraph to detect real-time phone fraud, okay, with 2 billion plus calls per week going into TigerGraph. And then here we have Visa that uses us for IT operational efficiency. Okay, so Wish.com. Wish.com, they have well over 300 million users worldwide from Brazil to the US. They use TigerGraph to build a customer 360 graph, a more personalized recommendations engine in real time. And they're able to increase e-commerce order value and reduce the memory size by 10x compared to the previous solution. And here you can see a quote from the head of data at Wish. Sorry. So the traditional approach to recommending products, cross-sell, upsell, they use things like product likeness, right? So you, as well as customer likeness, right? So people, this is the traditional Amazon approach, right? People who bought this have also bought that, right? So they offer that as a recommendation to you. If you bought a iPhone case, they also recommend you buy a one of the slips that come with it. All right. So Wish.com decided to use TigerGraph for a more personalized approach for upselling and cross-selling, right? So if they take into consideration not just your purchase history, but your browsing history as well. What have you searched in the past, as well as things like which product reviews you have read, which ones you have liked, and they put all that together for a more holistic customer 360 approach to cross-selling and upselling. And with that, they're able to cross $1 billion in revenue in just after 3 years of launching. And again, this is they have like 300 plus million users worldwide. Next, we have China Mobile using us for real-time fraud detection, phone scam detection. As anything with China, 6 million users. This is in Shandong province alone, right? And 10 plus billion phone calls every month with about 10K peak calls per second. Okay, so this is a real-time scam detection graph query, right? So it's a giant graph database of phone calls, essentially. And with this solution, they're able to cut down the number of scams that people try in China and improve customer satisfaction. So they're using TigerGraph to detect patterns or features, if you would, to say, you know, this phone call is coming from a good phone or a bad phone. So some example, right? A good phone would typically have a stable group of phone numbers that that person calls to on a regular basis, calls mom, calls dad. A good phone would have phone calls that go to a particular phone, and then there's in-group connections between those phone numbers. Also something called a three-step friend relationship, right? A bad phone, on the other hand, does not have a stable group of phone numbers they call to. The phone numbers that they do reach, they don't call each other. And lack of a three-step friend pattern here. Okay, so they use TigerGraph to detect these type of patterns or features, 118 of these total. And they use it as training data to feed into a machine learning solution. Okay, so by detecting these features using graph, they improve the quality of the training data. And machine learning solution is able to come back and tell you, yes, this is a scam call, no, this is benign, and so on. Okay, so 600 million phones, 15 billion calls, thousands of new calls per second. This is the Visa use case, okay? Implemented at Visa, and Visa is all about maximizing uptime, right? IT equipment, whether it's a data storage array or a router, a firewall, any one of these things going down is an issue for Visa, right? So what they're doing is when an outage happens, let's say this storage array goes down, they want to be able to make sure the stakeholders are alerted so that, you know, immediate remediation can take place, right? They can limit the downtime. So they achieve this by using IoT sensors at the arrays, at the network equipment devices themselves. When the IoT sensors send out an alert that, you know, an outage has happened, the alert updates a graph, and then immediately they do a query, a graph query, to do impact analysis to determine which servers, which applications are affected by this particular device going down, which applications and which services ultimately will be disrupted, and they're able to trace it back to the chain of stakeholders within the business units to alert, so that they can be proactive in getting on top of getting these things taken care of. Okay, this is actually in Graph Guru's episode number 9. You can watch it on YouTube. Register. Okay, and then Alipay uses TigerGraph for anti-money laundering as well as anti-fraud in real time. Again, huge numbers here: 520 million users, 256,000 payment transactions per second, up to 2 billion per day. And with this, they are able to invent fraud or AML alerts. Okay, so this is about HTAP, which is a term that Gartner had coined. It stands for Hybrid Transactional Analytics Platform, right? It's essentially a platform that can do both OLTP and OLAP together in one single place, okay? Not all graph databases are actually assets. Not all of them can actually support concurrent reads and writes. TigerGraph can do all of that. We are one of the few HTAP databases out there, graph databases out there. So as you see with China Mobile, with Wish.com, we are able to do analytics on live transaction data transactional data as they come in. There's zero latency between your transactional data context and your analytical data context, right? Zero friction. You're doing analytics on live transactional data as they stream in. With the use cases that we just mentioned, oftentimes TigerGraph is in the middle, aggregating various data sources, whether it's coming from the master data, employees, suppliers, and data is coming in from operational data, your transactions, your shipments, payments, and then we aggregate that with any kind of historical data that's pertinent, whether it's coming from data warehouse, data lake, and then use the power of graph analytics to power various use cases and solutions in these categories, whether it's a recommendations engine, customer 360, anti-fraud, anti-money laundering, supply chain, as well as to feed into machine learning systems. Okay, so now the fun part, right? Why is TigerGraph 40 times faster than Neo4j? Okay, first the evidence, right? We've run our own benchmarks, and you can go to tigergraph.com and download it. The source code, everything is up on GitHub. The data set is all there. You can recreate it and prove it to yourselves. Don't take our word for it. For a simple 2-hop query, we are like 40 times faster than Neo4j, 109 times faster than Neptune, and so on. The data set, right? We're using 2 data sets, something called Graph 500 and another one called the Twitter data set. This many vertices in the millions and edges in the millions. We chose these data sets. The question that comes up often is, this is small, right? So why did you do this, right? Why not go up in the terabytes and so on? The reason is if we choose a large data set, a lot of these vendors can't participate just because they're just not built for that sort of thing, right? So this is our own benchmarks. Download it, check it out yourself. If you're interested in the third-party benchmark that's of a larger data set size, right? So this article right here, dzone.com, it's an article, it's a benchmark published by somebody who did a 0.5 terabyte data set. And it's very interesting. If you're evaluating databases out there, graph databases out there, this would be something, and performance is of importance to you. We recommend you take a look at this article. This is the same one that we previewed earlier. Essentially, when we add more hops, like 3+ hops, a lot of the vendors, even with this small data set size, either ran out of memory or just time out, right? So it's not surprising, for me at least, that a native graph architected on an MPP architecture would outperform our competitors that are not MPP, okay? We wanted to do a large data set comparison. So we wanted to see if you have a large data set across 8 machines, what kind of speed up would you get, right? Would it be linear or not, right? The answer to that is we got a 6.7 times speed up. So not linear, but almost. Compared to Neo4j that, they can't do that. Neptune, Amazon Neptune, the algorithm we chose was PageRank, which is a very compute intensive algorithm. Essentially, the whole entire graph with every edge is traversed multiple times. So you can think of a large data set. There's going to be a lot of inter-server communication with this type of a benchmark. Amazon Neptune can't run PageRank because of the implementation of Gremlin, didn't allow that. I'm sure you could do something very custom, but out of the box, just using the standard Gremlin implementation, we could not achieve that. Loading speeds and storage, right? Very important. So in this case, you might think that, okay, Neo4j did a lot better, right? They are 2 to 3 times slower than TigerGraph. However, we are comparing ourselves with offline loading mode for Neo4j, right? So offline loading means while it's loading up, you can't do anything else. You can't do queries, nothing else, right? So we're comparing ourselves with that level. And you can see the rest here for Neptune. Storage, very important, right? Resources, right? So for here, different colors for the different vendors, right? We have very efficient compression technology, and on average about 50%, right? So if you have 1 terabyte coming in, we can cut that down to like 500 GB, okay? Compared to Neo4j, if you have 1 terabyte, you need 2.38 terabyte of storage. For Neptune, is even worse, okay? Now, this is important because depending on how you want to deploy, especially if you're deploying up in the cloud, or like Azure or AWS, right? This has major cost implications because the ability to do more with a lot less resources eventually translates into a lower TCO, a lower total cost of ownership. Okay, and we see this all the time, especially with people that are deploying up in the cloud. We're saving them a lot of money just from our compression technology alone. Okay, so why is TigerGraph fast? Why does it scale better than Neo4j, right? Number one, C++, right? If you look in the enterprise data platform sector, right? You look at the Oracles of the world, you look at Microsoft, SAP, even the NoSQL database vendors out there, like MongoDB, right? Every single one of them is written in C++. And the reason for that is because they are serious enterprise players. They know you can't get enough performance, right? If you're gonna, especially in this era of big data, right? Neo4j is Java, which is a great language for applications, you know, apps on your phone, maybe even a CRM like a Salesforce, but for a database kernel, it's probably a poor choice of language. Secondly, we are native graph storage, right? There's no impedance mismatch versus, you know, like a Graph 2.0 vendor, right? That you're not persisting it one way, and then there's an impedance mismatch with the actual graph representation. So no latency. Secondly, and thirdly, our MPP, massively parallel processing architecture, right? And ability to compress data, be very efficient. Last but not least, we have GSQL, right? It incorporates the best features from SQL. We borrow heavily from SQL whenever possible. We actually incorporate some of the features from Cypher, Gremlin, as well as Sparkle for MapReduce. Okay, it's Turing complete. We support recursive calls. You can program graph algorithms inside of it. Any kind of business logic is possible. It supports parallel execution. Okay, it supports parallel traversal of your graph with parallel computations and accumulation along the way using our accumulators. There's a white paper that compares GSQL with Cypher and Gremlin. It kind of walks through the thought process of how and why we came up with our own language instead of going with one of the existing ones. Okay. Okay, so lastly, just want to show some things that you can do to get started with the technology. You can download the developer edition for free. You can download the enterprise edition, which comes with a 30-day free trial. There's a developer portal for documentation, white papers, and so on. You also have a developer forum where you can sign up and ask questions about GSQL, questions about how you want to do a model, so on. There's an ebook for those of you who are new to graphs. Excellent ebook here called Native Parallel Graphs. We have the Graph Guru webinars that you can sign up. There's one every couple of weeks. You can watch those videos. And last but not least, every one of our Graph Guru webinar, or the entire data set, schema, query, GSQL queries are all available on GitHub. Okay, with that said, we want to open it up for Q&A.
Excellent. We have quite a bit of questions here. Let me start going through those one by one. Thank you for all of your questions. And it's lovely to see everybody being so engaged on this. The first question is, you mentioned data sizes. What is the small size data set for graph that you have seen? What's a medium size and what's a large size? So if you look at small, medium, and large size, what is it? What do you mean by that? Victor, would you mind answering that?
Yeah, sure. Yeah, so small, medium, and large, right? So small data set size would be in the tens of gigabytes, okay? A medium would be like 100 plus gigabytes, and large would be, 500 gigabytes to half a terabyte, to up to a terabyte, and so on. Okay, so some examples: Wish.com is a half a terabyte data set. Alipay is 10 plus terabytes. Open Corporates is 100 gigabytes and counting.
Excellent. Thank you, Victor. One more question here. The question is about if I have a small or medium-sized data set. If I have a small or medium-sized data set that's like less than 100 GB, do I need TigerGraph? Let me take this question. We get this all the time in the field. That's a classic question, right? Because a lot of people start their proof of concept with Neo4j, sometimes with other technologies like OrangoDB and others. And the question is, hey, do I really need TigerGraph, right? Do I really need this Tesla or the Ferrari of graph databases? And my answer is very simple. I'll give you an example of one of our recent customers that went live. Open Corporates went live with TigerGraph, and they selected TigerGraph. Their data set is around 100 gigabyte, less than 100 gigabyte, so and growing rapidly. But they selected TigerGraph not because of the size of the data set. They selected TigerGraph because they wanted to do 5-hop queries. So a hop in a graph database is, for example, when you go from a company to its subsidiaries, right? That's one hop. From the subsidiaries to related companies that are related to a particular subsidiary, that's another hop. So if you look at a corporate relationship database like what Open Corporates has, if you're going up the hierarchy from a subsidiary to its parent, from a parent to its parent, everything is a single hop. So if you're doing like 5 hops like that, it was very difficult to do it in real time with other graph technologies. And they selected TigerGraph despite their medium-sized data set for that functionality. The other example of that would be a time-constrained graph search. And what I mean by that is Open Corporate specifically deals with finding and reducing money laundering and corruption. And one of the ways that they help investigative journalists do that is to identify companies and subsidiaries that pop up for a short duration. So I'll give you an example. In June of 2017, company 1 has 5 subsidiaries, right? Subsidiary 1, 2, 3, 4, and 5. In July, they suddenly have 2 more subsidiaries added. The subsidiary 6 and subsidiary 7. Again, in August 2017, a month later, somehow those subsidiaries went away. And again, you have like 1, 2, 3, 4, and 5, but not 6 and 7. That's a very suspicious thing to occur because over a period of time, 2 subsidiaries were added briefly for a month, even for a week, and then they suddenly went away. That's usually an indication that those subsidiaries were used for money laundering, maybe for bribes, maybe for corruption. It doesn't always mean that, but it just begs the question whether it's something that is suspicious about that. So that's called a time-constrained graph search or temporal graph search. This is a functionality that first and second generation graph databases cannot really handle. That's another reason, regardless of your size of your data set, whether if you're trying to do more than 2 or 3 hops, you need to consider TigerGraph, the native parallel graph, with the scalability that it has to handle that in real time. If you are considering things like time-based search or time-constrained graph search, then you should consider TigerGraph. I'm going to do one more question here right after that. A good question here. Explain the edges. What do you mean by edges? Is it equivalent to a connection from one node to another? does it have a statistical meaning behind it? And then another question is, what is a vertex? What is an edge? Maybe you want to pull up a graph, Victor, and explain the vertex and edges real quick. And that way we can clarify that for the audience. And thank you. Please keep the questions coming. I still see that there are questions coming in the Q&A. So please keep asking them. Victor will keep answering those as and when he gets through it.
Okay, cool. So back to the schema, right? So this is a vertex type. This is an edge type, right? So a vertex is just an instance of a vertex type, right? So to kind of give you an analogy there, a vertex would be the equivalent of a row in a relational database. An edge is the equivalent of a relationship in a relational database. So an edge would be a foreign key, primary key pair. Okay. What's the other question?
Excellent. The other question was, Victor, was does the edge have any statistical meaning associated with it? No, not really. We are not really talking about statistical edges here. These edges simply mean the relationships between the vertices. So easiest way to think about vertex is business objects, right? Customer, product, citizen, location. Those are vertices. And then our relationship between those are edges. The easiest way I think about graph databases is if you tell a child to draw a picture, you describe them a business, you describe them an organization, how they would draw it on a piece of paper. That's exactly how graph database looks like. So a vertex is a business object, a business entity or organization, and then edges are relationship between those business entities.
Okay. So one question that also came in is from Gregory is how easy is it to alter the schema of the graph with reloading the data? It's fairly easy. We support dynamic DML for refactoring both the schema as well as the incoming data into that schema.
Okay, excellent. One more question, actually. It just keeps going. So one more question. How long does it take if I have a current graph deployment, either with Neo4j or another technology from first or second generation? How long does it take for you guys to migrate the data? And how long does it take for you to migrate the graph query? The queries, like Cypher queries, for example, or Gremlin queries. This is a question we get all the time. I always love to give customer examples there. It's easier that way. Typically, it takes a few weeks for us to migrate the data. Usually, the time spent is not in TigerGraph. It's mostly done at the fact that the business users and data scientists realize you can do a lot more with TigerGraph than what you could do with the previous functionality. So we can migrate the data literally in a matter of days, and we can translate Cypher queries in a matter of days. But then when they look at TigerGraph's capability to say, oh, I can do 5 hops now, I can do 8 hops now, and then they start to say, well, I have this query, I had this structured this way because of limitations of my current technology. Now I can do a lot more. So they go back and redesign those, take a few weeks. So typically you're looking at a 6 to 8 week migration of both data as well as queries. And you're looking at, a factor or 2 of magnitude. So 10 to 100 times faster performance for those queries immediately out of the box. And of course, your cost of ownership is much lower because for the same hardware, you can run 40 times more queries than what you can do with Neo4j, or 100 times more queries what you can do with Neptune. So your cost of ownership is much better. Your existing hardware will scale up for larger data set and also for larger number of queries. Let's see, there's a few more questions here. I'm just going to wrap up. If there's another question that we can address, we have maybe a few minutes over, Victor.
Yeah, so we can address one more, like how do you support your customers on the European side? Yeah, so we have a team based out in London that's growing. We have solutions architects out there that can help you with modeling GSQL queries, and we're flexible over here. We work European times as well.
Yeah, and I wanted to mention that we are also ramping up partners on in London and rest of the Europe. We have customers in Germany, we have customers in Switzerland, we have customers in London. So we're ramping up the customer base rapidly, and as a result of that, we are ramping up partnerships as well. So in addition to our own team, we are training up data scientists from partners who have experience of deploying graph deployments. And then we've started to work with them actually to design new solutions for customers. So if you do have a question, if you do have a requirement, feel free to reach out to us. My email address is very simple. It's Gaurav, G-A-U-R-A-V, like Victor, at TigerGraph.com. And Victor, what's your email address?
Yeah, my email address is victor.moey@tigergraph.com.
Perfect. Okay, so ask any of us, or sales@tigergraph.com, or just come to our website, download Developer Edition, come to the developer portal. We are happy to assist you any shape or form we can. We love to talk to fellow graph heads, both Victor and I do, and we have a whole team of data scientists here who are all focused on making sure that regardless of your size, whether you are a fintech startup, whether you're an energy startup, or you're a Fortune 500 company, we are geared to handle all of the questions here. Okay, with that, I'm gonna close out. I think we have answered all the questions here. There was a question regarding, can we load up the schema and create schema on the fly in TigerGraph? That's something that I wouldn't recommend to do for performance reasons. It's not advisable. We, of course, as you're loading up data, we can create schema and objects on the fly. So for example, if you have patient data that's coming in, we can create the patient data, additional patient data on the fly. We can deduce relationships on the fly. I wouldn't recommend that technically for a large data set, because you end up in spending a lot of cycles doing things that way. Given the flexibility of our interface in Graph Studio, it literally takes minutes for you to create a schema. And you can experience it for yourself by downloading the Developer Edition, create the schema in minutes, and you're ready to load the data in there. So with that ability, no reason to try to create dynamic schema on the fly. It's not something that I would recommend for a deployment perspective anyway. Okay, with that, we are out of time. Thank you, Victor, for joining us today. Thank you, everybody, for fabulous questions. Keep them coming. And we'll talk to you guys. We'll do this introduction to TigerGraph every month. We have data scientists like Victor who are out there in the field talking to all of you customers and prospects. So we'll do it once a month going forward, along with the regular Graph Guru session that's focused more towards the intermediate or expert users.
Thanks, everyone.